This lesson is more on classes and objects. We'll be looking at the private method, private state variables when we create them, or private methods, as opposed to public. So we've already seen the public keyword. We're going to see the private keyword now and what that means. And we'll also look at equality between objects and see if they're equal to one another or not. And depending on how we use equals, it'll give us a different thing. So in our browser here, this document will be made available to you. So let's take a look at this example. It's called sales tax. It's a new class called sales tax. And what it does is it calculates the sales tax for an item given the cost. So there's a couple of variables that we have as state variables, 3 actually, not a couple. We have cost, grand total, and tax rate. I want you to notice that cost and grand total are both public, meaning that they're available outside of the class. So if we're using this class in our main method in a different file, we can still use those and they're accessible. However, pay close attention now, this is new. We have tax rate and it's being declared as a private variable. Private meaning it's only available inside of the class where it was declared. Okay, so that means if we try to access tax rate in our main method, we'll have a problem because our main method, remember, is not inside the class. It's in a different file usually. But tax rate is something that is only available inside of those castle walls. Remember, going back to that analogy, we had a castle and we had a horseback rider riding up there telling in our constructor, and that ties in well with our constructor. So let's look at our constructor and use that analogy of the rider riding up to the castle walls, not being let in, but having some important information to share. So it looks like when we create our new object from the sales tax class, it's going to ask for a single value that's a double called C. It doesn't need to be called C. It could be just a number, and that's going to be our cost. And that's like our writer coming up with a piece of paper saying, okay, the cost is $12. So someone on the other side of the castle walls is going to say, okay, great, so it's $12. You can't come in, but we're going to take that information and write it down on our piece of paper that's not contaminated, and we're going to go inside of our castle and share that. Now that piece of paper that's not contaminated is cost, the cost variable. It's a state variable. Remember, C is in the wilderness. It's coming from wherever. It has to be vetted, I guess, by the gatekeeper at the castle gates, and it's going to cost. And then we have a couple of methods. We have a tax method that doesn't take in any parameters, but it returns a double. So it takes the cost variable and applies the tax rate to it. So cost times tax rate, and it tells us how much the tax is going to cost. Tax rate is not available outside of the class. So, but that's okay. We're only using it inside of the class here. Okay, now let's look at our main method. And the line that's in yellow is going to give you an error. And let's see why that is. So what's going on here in our main method? We have a new sales tax object from our sales tax class that we were just discussing. We've chosen to call it my cost. It's going to be a new sales tax object, and it looks like the price of the item is $9.99. All of those instructions and blueprints are above in the class, and you can access this document on our online learning site if you want to look at it more closely, because I know you probably can't see all the lines that you want to. But look at the next line that's in yellow. There's an error here because we're trying to take this new my cost object and access what tax rate is. And we're not allowed to do that because tax rate is private. Okay, so that's the whole point of private and public. You're probably asking, why would I ever use a private for a state variable or a method if I can just use public for everything? And you're right, you can use public for everything. However, it's good programming structure and good form to use private when it is appropriate to do so. So if there's a state variable that you're not using in your main method and you're never going to use it, it's a good idea to make it private so that when you go back and you look at your class later on, it's easier for you to understand how you created it, maybe a month or two later, or maybe someone else is looking at it and they want to understand how you programmed it. Okay? Now, let's take a look at something else now. This is when you have two objects and we're going to set them equal to one another. So let's see what that means. First of all, let's set the stage. we have a circle object called circ1. This is a new example now, circ1, and you can see that the radius is 13.5 just from line 1. I'm just highlighting what I'm talking about now. Now, circ1 exists. It's a new object from the circle class, and it has a radius of 13.5. It's pointing to this circle here. So far, circ2 doesn't exist. On line 2, we're creating a new circle object from the circle class called circ2. It exists, but it's not pointing to anything. It doesn't really have anything to point to. It's like a lost puppy or something. Then, circ2 on line 3, we're setting it equal to circ1. We're not creating, so what's happening is we're pointing it to the same physical object as circ1. So that's what happens when you use a single equal sign. When you set two objects equal to one another, they are now pointing to the same physical object. Okay? So just note, circ2 and circ1 point to the same physical object. Whenever you are using two objects, whenever you're using objects, the single equal sign is like a point to operator. Okay, new example. Rectangles now. We've got two rectangles. We've got rect1 and rect2. And if you remember back to our class that we created yesterday, it took in the rectangle class. It's the same one as yesterday, length and width. So length is 9, width is 4. In our first line, we are creating rec1 it's a new rectangle object with a length of 9 and a width of 4. Then we go ahead in line 2 and we create a new rectangle object called rect2 with the same properties. However, they are distinct objects. They point to two separate things, even though they have the same values. I want you to think about two brand new Teslas rolling out of the Tesla plant. They're both maybe like a nice dark blue color, and they are two separate objects. However, they both have full charge, they both have no scratches on them, and they both have the same trim level. Okay, so in that case, they're identical, but they're two separate objects. So that's what I want you to think about here. We have rec1 and rec2. Even though they have the same values, and that's what I'm reading from the note here, they are two separate physical objects, and that's what the diagram shows. Now let's say that we were using an if statement and we were using the double equals. So we've been using two equal signs to compare things. However, when you're comparing it with objects, it's a little bit different. So we had our circ2 and circ1 example up above where they both point to the same physical object. When we take those two things and we try to see if they're equal to one another, it's going to return true. Yes, they are the same physical object. However, rec1 and rec2, even though they have the same values, they look identical, they look like clones of one another, they point to two separate objects. So when we try to use double equals on it, we will see, oh my gosh, and a spider just crawled onto my screen. Anyway, that's okay. I will put it in a cup and put it outside later on. Wow, that has never happened. Anyway, rec1 and rec2, they are false. When we try to see if they're equal to one another using two equal signs, we will get false. Okay? Because they are not the same. Because they are not the same physical object. Okay, so looking at another way of comparing two objects with the dot equals method, it behaves exactly the same as two equal signs, and that's when you create your own class. However, with strings, it's different. It's a different story with strings and equality. So with strings, let's look at this short program here. I'll make the font a bit bigger for you. So we have a program called string test here, and this is the last part of the lesson. With strings, if you are comparing to see if two strings are the same, well, we have str1 and we have str2, and they're both set to Notre Dame, but they're two distinct objects. They're pointing to different things. If we try to use the dot equals method here, we'll see that it returns true. So they're pointing to separate objects, but this is the dot equals method is used with strings if you want to say, well, do they contain the same things? Are the contents the same? Okay. However, equals equals will return false. Equals equals is used with strings to see if they are the same physical object, which is something you never really do. So with strings, you're almost always going to use the dot equals method. So here's the note or the summary at the bottom. The note says dot equals with strings just compares to see if the contents are identical. They can be two separate objects. This is usually what we want to find out with strings. So use dot equals with strings, period. Don't use equals equals. So let's see what summary is. Strings. Dot equals will return true with strings if the state variable is the same, even if they are separate objects. If the value of the state variable is the same. If the value is the same, okay? All other objects, dot equals will return false if they are the separate objects, even if their contents are identical. And equals equals works the same for all object types and will return only true if they point to the same object, okay? You may have to watch this again. I'm going to recommend that you look at Blue Pelican Java and look at their lesson 16. They explain this as well. There's some really fine points here that you have to make sure that you understand so you don't get those things confused. So that's the end of the lesson.